This is the mission 46 happening in Space Analog Station Habitat Marte. It's a virtual mission with participants from Ireland, India, Kuwait, Brazil, Philippines, and Canada. Today is July 29th. Presentation from as uh, Ravva Saranya. Ravva, thanks so much for your interest in the mission, and you are welcome yourself.
Thank you so much, Professor. First of all, I would really thank you for giving me this opportunity today to participate in the Mission 46 Perseverance of Habitat Marte. Uh, as the in charge of Sanitation Centre, today I would like to talk about it. So here, as you can see, these are the contents of this particular presentation, and let's get into it. So yeah, as you can see, this is the proposal of Habitat Marte, and here are the various stations and centers which are planned. And as you can see, the first one is Engineering Center, Launch Center, Health Center, Sanitation Center, Greenhouse, Power Station, and Main Station. And today, let's discuss about Sanitation Center. So the main thing here is to decide about a possible or a virtual concept. After doing a bit of research about this, I found Ansil Hab to be one of the most feasible solutions. As you can see here, the habitat has been arranged in the form of stages, and each stage has compartments to different crew members. And I found it to be very compact. And also, as you can see here, it is a proposal by NASA, which is Mars Ice Home concept. Here, as you can see, it is shaped in the form of an igloo, and it indeed uses ice bags as a shield in this particular habitat. And this particular concept here is from my favorite movie, which is The Martian. And uh, in that movie, this particular home was called the Hab. And as you can see, that particular concept was this. And yeah, before we go to Mars, one of the major technologies which can be used there is 3D printing. And as you can see here, this is a huge automatic 3D printer which is actually building homes on the surface of Mars. And this particular Ansel habitats can be further developed in this way using these kind of 3D printers. 3D printing is one of the major technologies which can be used for explorations like this. And it is also one of the majorly used technology even on International Space Station. And here in this picture, you can see an interesting fact, which is our Earth, which is in the form of crescent. Yeah, from as I read it from different articles, it is believed or estimated that from the surface of Mars, the phases of Earth can be seen just like we see the phases of Moon from our Earth surface. From Mars, we can also see Moon as well because of the distance, maybe. And then yeah, I would like to explain a bit about the Mars Ice Home concept. Here, as you can see, it has all the major components, just like a home which is on our Earth. And but if you can see, one major difference here is the ninth component, which is the airlock. Airlock is one of the major essential units of a habitat to protect the astronauts from dust storms and other radiations. Dust storms, I mean to say, this particular airlock just filters away all the dust and air from the surface, from the human body surface or their spacesuit surface, and then they would enter into the habitat, which makes it safer. And this is one of the major issues of sanitations as well. And Yeah. So in Sanitation Center, as we all know, for proper functioning of a habitat, say it is on Mars, on Moon, or either on Earth, one of the major requirements is to have a proper sanitation facility. And and on surfaces like Mars and Moon or any other interplanetary missions, as the resources are very limited, it's very important for us to have a closed loop system. And what I mean by this is to have the usage of regenerative methods. And that can be done using a lot of technologies, which I'm going to mention later on. And as you can see, these are the key elements of sanitation, which are pretty common wherever we are in this particular universe. And the main elements of these sanitation center would be the collection of waste and processing it, water recycling into required products. This particular, say, organic waste or human waste, there are a lot of technologies which can be used uh, to convert them into required products. And also, one of the major issues on Mars, unlike Earth, is the maintenance of atmosphere, but with the help of either air filters or airlocks, or by maintaining a Earth-like atmosphere inside of the habitat. Now, yeah, I also believe um, just with the sanitation, we should also have a sustainable sanitation into the consideration, because it is definitely going to be a catalyst for development. And in this particular case, we can look at several aspects, which are uh, biogas, fertilizers, and many other things which are mentioned here. I would like to discuss about few things here, which are the source of water. We can, what do you say? Use filters and all of that, and get drinking water from all of that wastewater by using a lot of technologies, just like we use UV filters and all of that on Earth here. And yeah, one of again an interesting fact is that a recent project or experiment done on International Space Station has proven that human waste together with water and food can be put in bags, and it can be used as a shield against radiation. On the surface of Mars, there is a lot of cosmic rays, and in a very pretty interesting and weird way, human waste can be actually used in this way. So the reason being that liquid water can be actually a better shield than metal, because it has got nuclei power per volume, which is the actually key to block the cosmic radiation. So this was one of the interesting facts which I've uh, come to know because of this particular presentation. Then, yeah, the technologies to build in the habitat, especially for sanitation center, are these. So, I particularly found these solutions from the Reinvent the Toilet Challenge and Expo Gates Foundation. So, here is the first one, which is the nanomembrane toilet. I found this to be very fascinating, because this particular thing literally treats the human waste on site without the usage of energy and water. As you can see, uh, it works in this way, without any use of any sewage system or pipeline system or any other external system. It takes in the waste, it recycles it, and gives out running water. As this particular toilet here has a rotating gear system, where the waste gets into it, and the solid material settles down and the liquid material settles up due to the density. And there is a Archimedes screw which transfers the solid waste into another compartment, and that compartment basically divides the waste into small pellets, and those pellets are then sent into a combustion chamber here, and they are burnt. And the liquid water which is and the liquid water which is present here, gets heated up into steam with the help of the sorry, not really steam, gets heated up with the help of the heat generated of the because of the solid combustor. and this particular water is then passed through gas treatment, where the pathogens are removed, and there we can have a storage tank over there where we can have not really drinking water, but water which can be used for several other uses. This one particular aspect I really liked, and it made me believe that these kind of nanomembrane toilets can actually be used in each center of the habitat. Now, another interesting technology is the usage of omniprocessor. This particular omniprocessor is again a self-sustaining and independently developed processor, because it does not really utilize any external energy. And here it it uses these technological approaches like combustion, supercritical water oxidation, and pyrolysis. So, if we are looking into a large scale model, I think omniprocessor then come into picture. And yeah, smart sanitation. Smart sanitation would be really helpful in the maintenance of sanitation in several centers, in the maintenance of several centers of the habitat. Here in smart sanitation, we can use sensors which thereby capture the molecular characterization of waste, and they transmit the data to connected centers, and then this particular data is processed and analyzed, and based on this data it can be helpful for us to maintain, repair, clean, and also to collect the waste. This smart sanitation can be used not only on a Mars habitat, but also it can be used, say, on any particular center. Then, yeah, just like waste management and water management, another important management on Mars is the atmosphere maintenance. And here, the main key point is to maintain the level of oxygen and the removal of carbon dioxide, and to maintain atmospheric conditions like pressure, temperature, humidity. And as we all know, Mars is full of dust storms, and it's very important for us to manage that dust very regularly. And we should also take care of that dust management. And we have to maintain a particular indoor air quality, which which is very essential for the life support system of the crew. Then we have HVAC, which is heating, ventilation, and air conditioning, which is again another important aspect. Yeah, unlike the homes on Earth, the main important thing on the homes of Mars is the airlocks, which are very important to be placed before the entrance of every center. Also, we need to have high efficiency particulate air filters inside the habitats. There should be air purifiers to kill the pathogens that might cause any illness or, say, allergies or sickness. And here's another interesting fact, which is MOXIE. So I'm very glad that I'm participating in this mission, where tomorrow, July 30, there is a launch by Perseverance by NASA. And on this particular launch, they are carrying this MOXIE instrument, which is the Mars Oxygen ISRO experiment, which is mainly used to produce a small amount of pure oxygen from the Mars atmospheric carbon dioxide. And this particular experiment is definitely going to help for further exploration of further human exploration. So yeah, I'm so excited for this particular mission, and I'm eagerly waiting for MOXIE's results. And then, yeah, sanitation also includes personal hygiene, and it is also one of the major aspects. And since water and the resources like detergents and all of that are very limited on Mars, there have to be many alternative solutions to be used. And uh, solutions like washing clothes without using water. And when I read about this particular technique is actually used even on Earth, by using nylon polymer beads and steam cleaning. freezing of clothes, and also there is an LG freezer which actually looks like a fridge, and that particular wardrobe we can just hang our clothes, and it basically refreshes and deodorizes the clothes rather than washing them. So this might be another interesting thing which can be used there instead of just washing clothes, maybe, since we don't have much water there. Yeah, other aspects like dental hygiene should also be taken care of. uh, you know uh, spacesuits are spacesuits are very essential, as as of now, since the Mars is not terraformed yet. Spacesuits are really required because mars is Mars atmosphere is covered with more than 90% of carbon dioxide, and that really requires spacesuits equipped with oxygen regulators. And we should also maintain the spacesuits such that they have low dust retention and release, and which are very easy to wear or very comfortable. And yeah, again, one more fact is that nanotechnology solutions for self-cleaning dirt and water repellent coatings. So nanotechnology can also be used here. If when I say nanotechnology, you can compare it to a lotus plant. Even though the lotus plant lives in dirty water, if you look at its leaves and its petals, they are very clean because of the properties of its material, or its surface tension, or all of that. So the same kind of technology can be even used in nanotechnology, and that again can be a solution for personal hygiene and other cleaning purposes. Then yeah, if you look at the resources per person on earth, for oxygen, drinking water, and all of that, these are the per kg requirements per day. And when you compare the same of these resources, if the person lives on Mars, these are the particular readings. And as you can see, the reduction of resources has decreased so much here. The drinking water has been tremendously decreased to 83.8%, and the water for food is decreased to 80%. And these are the several other aspects of sanitation which are mentioned here. As you can have a look here, we actually utilize 5 liters 5 kg or 5 liters of water, and this this is a huge amount here. And here, when you look at it, all of them are reduced to more than 80%, as you can see. So resources are definitely limited on Mars, and my estimations based on this particular reference are here. Then yeah, life support system. So say sanitation center or any other center. So these are the particular functionalities or the sectors happening inside the habitat or the center. So basically, this is the crew, and the crew lets out CO2, and here the crew needs O2, which is oxygen. And here there should be sensors which are able to detect fire and any other emergencies. And here we have temperature and humidity control, which is really necessary for a habitat on Mars. And here, as you can see, the sanitation role comes apart. Here is the waste management, and where the waste products are collected. Here, as you can see, the liquid water, liquid waste, or the urine recovery. And here you can have a particular sector where this particular liquid water or liquid or solids are processed into, say, drinking water also. And yeah, it can be used for hand washes, showers, shaving, and whatnot. Is as I told you, sustainable sanitation is definitely the catalyst for development in this particular center. And then yeah, so these can be few of the resources which I thought would be required to be carried from Earth. One of the biggest thing is the 3D printer, and then, as I mentioned, nano membrane toilets can be, set up in each center of the habitat, and then food and water for the initial phase. Before we at least try to manufacture there on the Mars, we need to carry them, space suits, seeds and fertilizers, all these filters and purifiers, fuel, say for cooking or anything, solar arrays, and power systems like nuclear, electrical, or any wind turbine power systems. And one major aspect, which is greenhouses. I think these are the resources which might be required to carry it from Earth. And yeah, as the in charge of Sanitation Center, I believe these would be my duties. And first one is to monitor all the technologies related to the center, then communicate and maintain daily records of each center sanitation condition. In this way, there is an effective solution. Then also thinking about regeneration ideas from the collected waste. So this particular sanitation center might require engineers, operation managers, space plumbers. One of the astronauts can be that, cleaners, designers, inspectors, biochemists, etc. And biochemists, because we are dealing with a lot of sustainable solutions like generation of biomass, biogas, and several other things like that. So then, yeah, number of astronauts for this particular center might really depend upon the habitat size and the goals of the habitat. But I would say for effective maintenance, as there are 7 centers present in the habitat, if there is an each person should be monitored. Each center should be monitored by a separate person, and in that case, probably this sanitation center might require 7 people for effective maintenance. And yeah, food production in the facility, as you can see, hydroponics and aquaponics are two major technologies which can be used for the generation of food on habitats on Mars, because they don't really use any soil and all of that. And I read that aquaponics are much more efficient than hydroponics. And the difference between them is that in aquaponics, fishes and all of that are also grown along with the plants. So yeah, and also in this food production, as we are looking into regenerative methods, we can also look at some ingenious methods like usage of biomass or biofertilizers to plant crops on Mars, just the way it is done in the movie Martian. Yeah, as you can see here, in that movie, Matt Damon actually uses human solid waste for the production of potatoes, and that's how he survived there, as we can see it in the movie. And then, yeah, this might be one of the greenhouses which can be set up in the Mars habitat. Then, yeah, in the facility, there can be possible activities. There are many activities which are to be maintained, and one of them is to monitor these wastes and divide them into several categories so that they can be used for to convert into effective uses. Then reviewing recycling processes, reviewing the resources, usage of these biogenerative products. It is very important to staying healthy. So I have also read that these particular human waste and everything, all of these can be filtered, and from some protein rich capsules can also be made out of them. And on Earth, a research was also based on that, and there are really few capsules from that. Here in India, we consider organic waste of cow to be very holy or precious, and considered to be very healthy and all of that. So we can also utilize these particular biogenerative products in that way. And as I told, F smart navigation is definitely going to play a major role in the effective communication between centers with sanitation center. We should make sure to refresh the center, every single center, every once in a while. Yeah, I would. I believe prevention is better than cure in this particular case, and regular maintenance is really required. And yeah, a few guidelines to other facilities or the whole station would be to maintain strict sanitation protocols, to have regular communication with the sanitation center, to enable hygiene and maintenance. Air filters should be installed, and they should be maintained and cleaned. The dust has to be cleaned every once in a while. Just say if there is any malfunction, in any sanitation systems present in any center, that should be reported immediately, say with the help of smart sanitation, or with the help of the sanitation crew present in that particular center. Yeah, it is really, really very important to have an airlock installed at every center's entrance. And yeah, regular collection of waste is also very important. Yeah, just like how sanitation is important on Mars, sanitation is indeed one of the major pressing issues even on Earth. And effective measures should be taken. And on Earth, there are a lot of rural areas which are to be still educated on this particular aspect. As we already know, biogas is already being used in on Earth as well. And right now, because of the pandemic, a lot of people are installing air purifiers in their home. So this is again another activity which is similarly followed, which can be similarly followed on Earth as well. Yeah, we can also see, as I have spoken about the Omni processor, so it has the capability to convert the wastewater into drinking water. So that's another possible activity which can be applied on Earth as well. And usage of biogenerative technologies. One major thing would be to use biogas for the preparation of cooking here. And yes, again, I would like to mention that sustainable sanitation is the key. And I guess I'm at the end of the presentation. Yes, these are my references. And thank you so much.